Hi everyone, welcome to another class of MBA CAT Fast Test. This is Shubham Jaiswal, and today we will be continuing our topic from factors where we have last left. So, how to calculate sum of all factors? First of all, let's revise again how a factor of a number is made. Let's say the number n is made from prime numbers which are p1 raised to any power n, p2 raised to any power n, and p3 raised to any power n goes on till pn raised to any power. It could be a pq or something like this. So a factor is made from any power of p1 multiplied with any power of p2 multiplied with any power of p3 and goes on till n, and now it becomes a factor. Let's say power of 2 multiplied 2's first power is 2 to the power 1 multiplied with 1 from 3's bracket, or it could be multiplied by 3, it could be multiplied by 25, something like this. So sum of all the factors can easily be calculated by taking sum of all the powers of prime, which when multiplied by sum of all the powers of other prime which are available for the value n, and then multiplied by sum of all the powers of another prime which are available for the values n. For example, here for 5400, which is the number, the 2 power of 2 is available till 2 cube, right? So you take sum of all the powers of 2 till 2 cube, which will be equal to 8 plus 4 plus, let me write over here, it will be equal to 8 plus 4 plus 2 plus 1. If you sum up all these values, it will become, if you want, here you want are calculating sum for 5400, right? So sum of powers of 2 will becomes 12 plus 3, 15. Similarly, it goes for 3 as well. This becomes 27. This becomes 9. This becomes 3. And this will become 1. 36 plus 4, 40. 15 into 40. And this will become the last for 5. It becomes 25, 5 and 1. 31. Right. So if you multiply this, you will get the value of sum of all the factors of 5400, which will come approximately 126, 1260 into 15. This is gonna come 18600. So sum of all the factors of 5400 is 18600. Now let's say in another condition, the question is being asked to find out sum of all the factors of 5400 which are odd. What you do, from the prime bracket available for 2 power of 2, do not consider 2, or else the number will become even. And we wanted to find the sum of all the factors which are odd only. So we eliminate or we forget the value of 2 to the power any other powers. We just consider this value 2 to the power 0, since it will make the number and factors remain odd, and we consider all the other factors as which we have considered last time as well. From here to from 2's we consider it 1, and again we are finding here this time some odd for the value 5400, right? This will become 1, and this we have calculated 40, and this we have calculated 31. What the value will come? It will come 1240. So this is how you calculate sum of factors which are odd. Now moving, if you wanted to calculate sum of all the factors which are even, what we do here, we want all the factors to be even. So what we will need to do, we need to make sure that the factors which we are taking into evaluation is multiplied by 2 at least once. So what we do, we forget this value 2 to the power 0, and we calculate rest sum of all the powers of 2 variables till the maximum power. Here it is q. So what we will do, the total sum was earlier 15. If we remove 1 from this, now the sum becomes 14. Sum we are going to calculate even for 5400. Okay, fine. And then all the things other than to no need to you disturb the things, you can just write it as it is. 3 cube summing till 3 cube 27 plus 9, 36 plus 4, 40. This becomes 40 again, and the 5 square will become 31 again. What will this become? This will become approximately 17,360. Right. So this is the sum of all the factors which are even. What we have done here extra is we just forgot it, and the 2 to the power 0 from the bracket of 2 and moving. Now, if you wanted to find sum of reciprocals of all the factors, it will be sum of all its factors which when divided by the number itself. How did this come? Okay, let me tell you. Let's say if you wanted to, if n has factor f1, and we are going to calculate the sum of all these factors f1, f2, f3, and it goes on till 1 by fn, and this is the whole number. Let's say we are calculating for n. So now what will happen? If, well, first of all, you will need to take LCM of all this, which means in LCM you need to find a number which is a multiple of all this number. Obviously it is n, right? And in the above, if f1 is a number and it is a factor, so it will have another factor fn. Let's say for example here in the case of 5400, 1 into 5400. So for 1 there is a 5400, for 2 there will be 2700, and these both will be the factors, and right. So what we will need to do, so when you calculate for this f1, here it will become fn. F1 into fn will give the number. Similarly for f2, consider another fp, and then it moves on until last you will get what f1 will be there and f2 will be there. And what is all this? These are basically sum of all its factors divided by the number itself. So that's how we get sum of reciprocal of all the factors is equal to sum of all its factors divided by the number itself. Moving on. Now let's say we have to calculate factors which are available at end position. So what we need to do, we have, let's say for 5400 we have already calculated that 5400 as our total factor of 48 factors are there in 5400. Now let's say if you wanted to find out the factor which will come in ascending order in the 48 number, easily you can say the value will be 5400. Why? Because that is the last factor. But what we have actually done, the first factor of 5400 is 1 and the last factor will be 5400, the number itself, and the product of these two is 5400. Similarly, for second position, whatever the number will be, which means the prime number available at second position here or the factor is 2. Right. So what is the other multiple of 2 which when multiplied will give 5400? Correct. 2700. So, so if someone asks you what is the which is the factor which will come at 47th position if arranged in ascending order, so you can directly say 2700. Why? Because you have calculated that in second position 2 will come and its multiple is 2700, which will give 5400. Similarly you can do for other numbers as well. If you are supposed to calculate for 46th position, you just know key 3 is gonna come here. So so 3 number multiplied by which number will give 5400, that will give your answer for the number of factors which will come at the 46th position, right? Moving. Calculate factors of 120 which are not factors of 180. What we will need to do, we will need to find the HCF of this number and the HCF of this number. For 120 and 180, the HCF here is 60, right? So all the factors of 60 will be included in 120 and included in 180. So, and we need to calculate the factors of 120 which are not factors of 180. So first what you will need to do, you will need to calculate the total number of factors of 120, which is equal to, this is made of 4, 3 and 10. So 2q into 3 to the power 1 into 5 to the power 1, this will give 4, 2 into 2, it becomes 16. So 120 will have 16 factors and you need to calculate the factors of 60. I will explain why we are doing this. Factors of 60, it is made up of 4 and 15, which means 2 square into 3 into 5. So 60 will have here 12 factors. Now see, now in this 16 factors, 12 factors will be available for 120 as well, and 12 that those 12 factors will be available for 180 as well. All that's left are the 16 factors minus 12 factors, which will be 4 factors. These are factors of 120, but not the factors of 180. But not the factors of 180. Let me also tell you which are these factors. These are 8, 24, 40, and 120 itself. So these are the four numbers which are factors of 120, but not the factors of 180. Okay, moving. Perfect squares have same number of factors before and after n for n squares. Okay, so let's consider a number n square. We know that by now that a perfect square will have odd number of factors, and let's say n will always be in the middle value. For 36, let's say 6 would be the middle value. It will have same number of factor x which is before n. For 36, 6. So 6 will have the if S6 has n number of factors before 6, then it will have n number of factors after 6. This is what is written by the statement over here. Moving, we have already seen how to convert from numbers to how many number of factors it has. Now I will be seeing, if we have already been given the number of factors, how to convert it into back the numbers. Let's say for any prime number, it has only two factors, the one and the number itself, which is 2. How did we obtain? We added 1 to this power and we got 2. So if you wanted to go back, you just need to remove 1 from this and you will have your answer. Right? P to the power 1, which means 2 factors. If it has, it is a prime number. Let's say if it has 3 factors, it will have 3 minus 1 p square. It is a power of prime squares. Now let's say, for if a number has 4 factors, this 4 could be written as 2 into 2, or it could also be written as 4 into 1. Now you subtract again, like we did here, from we subtracted minus 1 from the total numbers of available. So here it will become, it could all I become either p1 into p2, or it could become from here also as well PQ, right? So from here on, if the number has multiples, then you will need to make cases over here, right? Moving. If you wanted to calculate number of phase, n can be written as sum of two coprimes. Whenever this question comes, sum of two coprimes, you will just need to go to the Euler number. Euler number, I would like to remind again, is the total number which are available before n for n which are coprimes to n. So the number of phase, if you wanted to calculate unordered, will be the number of coprimes available divided by 2. You have them, you will get unordered ways. And if you wanted to find them ordered, which means the variables are defined, so you do not multiply by half, or you just put the value there, which is the total number of coprimes available. Now moving ahead, if number of ways n can be written as product of two coprimes, what the question has asked, if the number n, it has to be written as product of two coprimes a and to B. Now what does this mean? This means that this has nothing in common. Okay? Common, nothing. Which means if n is made up of P1, or if n is made up of P2. So the whole power of prime either goes in A, whole power of primes either goes in B. So P2 or P1 or any power of prime will have two options to go. P1 will have two options, P2 will have two options, P3 will have two options. And remember, if it can go here, it can go here. We are talking about the case in which it is ordered, right? So for if the prime numbers are n, so you multiply it with 2 that many times. For here in this case, if we have 3 prime numbers, so it will have number of ways available, 2 into 2 into 2, 8 ways, and these are ordered. Similarly, if you wanted to find for unordered, unordered divide by 2. Why? Because we have already taken the classes for P1 when it is here, which means all the other factors will be here or all the multiples will be here, and then we have again taken P1 when here, all the other multiples will be here. So that's why this is a written key. Even if you wanted to find unordered, you just need to divide the total number of ways available by 2. Fine. Okay. Okay. We will continue remainders in the next video. Uh, I hope the learning helps you, and thanks for watching.